Hi guys, hope you're having a great day. Welcome to one of my favorite topics in pre-calc, which is composition of functions. I think it's really fun. Hopefully you think it's really fun too. I'm going to go ahead and share my screen. So composition of functions, you've done things with functions before. You've added them, you subtracted them, you've multiplied them, and you've divided them. But now we're going to kind of put 2 and 2 together. So that is called composition of functions, when the input is a function rather than just a number. So you've seen things like f of 3, where the input is a number. But now we're going to say f of 2x plus 1, where this represents another function. Okay? So the domain is the set of all x in the domain of G. So it's that G of x is in the domain of f. Now, that is a lot of words going on. But essentially what that means is you have to take into account the input of the function, so what you are plugging in, and then also the output or the outcome of the function. Okay? All right, so let's look at an example. Okay? One thing with notation, sometimes you will see this written with an open circle. Okay? This is f of g of x. This says the same thing, f of g of x. You may see it written one of two ways. They both mean the same thing. Okay? Composition does not work both ways, so f of g of x is not necessarily the same thing as g of f of x. And let's go ahead and look at that. So f of g of x means, what am I plugging in to the f function? I am plugging in g of x. So we know f of x is 3x minus 5. So if I'm plugging in g of x, I would do 3 times 4 minus x minus 5. Again, instead of x, I'm putting what g of x is. I can distribute this, 12 minus 3x minus 5, and get negative 3x plus 7, or 7 minus 3x. So that is f of g of x. Okay, now let's go backwards. So we know g of x is 4 minus x. So to get g of f of x, I'm going to plug in f of x. 4 minus 3x minus 5. I can distribute 4 minus 3x plus 5, or negative 3x plus 9. Again, those are not the same thing, so it's not commutative most of the time. You can't go back and forth and have it equal the same answer. All right, so let's look at one with domain. So again, f of g of x. This right here is saying f of g of x. It's saying take g of x and plug it into f. Okay, so I see g of x here and I see f of x. So wherever I see an x, I'm going to put g of x. Okay, so it looks something like this. Let's go ahead and simplify this. I know if I square this, I square the top, square the bottom. So I get 1 over x plus 2 squared minus 3 over x plus 2. I'm going to go ahead and simplify this to get a common denominator. So I'm going to multiply by this by x plus 2 on the top and bottom. And I get 1 over x plus 2 squared minus, I can distribute this, 3x plus 6 over x plus 2 squared. When I simplify, I get negative 3x. 1 minus 6 is negative 5 over x plus 2 squared. So this is the final composition of f of g of x. Now, to determine the domain, you have to take into account two things. One is the input of the function. So what is the domain of g of x? Well, we know that's a rational function that has a vertical asymptote at negative 2. That's from last unit. Okay, so that means negative 2 cannot be included in the domain. And then I'm also going to take into account the output. Are there any other restrictions in this output as to what x cannot be? Now, I notice here that x also cannot equal negative 2, but that's not any change or anything added to my domain restrictions. So the domain of this would look like negative infinity to negative 2, parentheses because not included, negative 2 to infinity. All right. All right, let's look at one more. Let's look at part B. Okay. Again, I'm going to erase this just so we have room. This is doing the same thing, but it's going backwards. We are doing g of f of x. So instead of plugging in g, I'm going to plug in f. Okay, so 1 over x plus 2. But instead of x, I'm using f of x, which is x squared minus 3x, and then plus 2. All right, so this is g of f of x. Again, what did I plug in for x? I plugged in f of x. Where this x was, I plugged in x squared minus 3x. All right, I can factor this in my denominator to find my vertical asymptotes. So my vertical asymptotes are 1 and 2, okay? So again, when you're talking about domain of composition of functions, you have to take into account the input, in this case, f of x, that's what I plugged in, and the output, or the outcome of the composition. Now, the input, f of x in this case, is a polynomial that has a domain negative infinity to positive infinity. So there's no restrictions there, okay? But in the output, I see I have 2 vertical asymptotes, so that domain will be negative infinity to 1, 1 to 2, 2 to infinity. Okay. All right, let's look at this graphically now. All right. I like to rewrite these a lot of times as f of g of 3. Okay. Again, that just says what are you plugging in? It's a little bit more visual there. So in this, you want to work from the inside out. You want to find g of 3. So if I go g of x 3, that should be 1. So this right here is 1. So then I want to find f of 1, which is 2. So my final answer is 2. Again, working from the inside out, evaluate what's inside, and then plug that into that next one. All right, so this says f of g of 4 times g of f of 1. Okay, so g of 4 is 0. So f of 0 times g of f of 1. Let's see, f of 1 we said was 2, so times g of 2. Okay, so then we have f of 0, which is 4, times g of 2, which is 2. So my final answer should be 8. And then finally, f of g of 4. Okay, again, work from the inside out. G of 4 is 4. So then I have, ignore me. That was f of 4. Don't do that. G of 4 right here is 0. So then I have f of 0, which is 4. Okay, notice that this piece right here was the exact same as this because that was the same question. Okay. All right, let's go ahead and jump then to 7b that says composition of functions. We're now going to do the same thing but from a table. Again, just break it down step by step. Okay, so if I look at this one here, I see 2f of g of 2. So I'm going to start with the inside g of 2. Reading this table, g of x when x equals 2 gives me negative 3. This is the part I'm looking at, g of 2. So then I have 2f, and we said g of 2 was negative 3. I'm going to keep moving down on that same one. F of negative 3 is negative 4. So I have 2 times negative 4, which is negative 8. I'm going to need to do the same thing on the second piece. Okay. Start with h of 0, work from the inside out. H of 0 is 3. So plus 3g of 3. G of 3 is 2 plus 3 times 2. Okay. So I end up with plus 6 is negative 2. Okay. So that would be my final answer there. All right, next we're going to do the same thing on part B. So start with the inside. G of negative 2 is negative 1. So I have h of negative 1. Let me erase what I have here so far. All right, times f of g of 2. Well, let's see what g of 2 is. That's negative 3. Okay. Then we can keep going. H of negative 1 is 1.5. Times f of negative 3 is negative 4. Okay. So if we have this right here, okay, 1.5 times negative 4, 1.5 is 3 halves, times negative 4 is negative 12 over 2, which is negative 6. Okay. All right, we're going to look at one more, which is just an application question. All right, so this one says the volume in cubic meters of a weather balloon is given by V of r equals 4/3 pi r cubed. If the radius is increasing at a rate of 1/2 t cubed, where t is greater than 0, find the volume as a function of t. So essentially what this is saying is instead of V of r, I want V of r of t. That's the composition that you're looking for. You're taking V, which is the volume, as a final function, but I want it as a function of t. So I need to take this and substitute it in for r. So 4/3 pi, and then instead of r, I'm doing 1/2 t cubed to the third power. All right, when I raise things to a power, I raise everything to that power. So 1/2 cubed is 1/8, and then when you raise to a power, you multiply the exponents. So if I wanted to simplify this, I would get 4 over 24, which would then simplify to 1/6. So I get 1/6 pi t to the 9th. And that is find the volume as a function of t. Okay, so that is V of r of t. Again, composition of functions can be kind of fun. If you get the hang of it, it's not too bad. Again, it's just the idea of instead of inputting a numeric value, I am inputting a function and evaluating it from there. Hope you have a great rest of your day.